Today we're doing a deep dive into a piece of hardware that it solves a problem most of us don't even realize we have until we hit a wall, literally.
Yeah, we've pulled the specs for the NTI ST-FODP14-MPO-200M.
Which is a real mouthful of a name.
It is. But what it does is basically an engineering cheat code for video signals. It's an 8K DisplayPort 1.4 extender.
Right. And our mission here is to unpack how this thing can move a massive and usually very fragile 8K signal over 200 meters.
Which is what, like 2 football fields?
Exactly. I mean, if I try to run a standard DisplayPort cable more than, say, 3 or 4 meters, I start getting weird sparkles on the screen, or just a total blackout.
That's the copper limit. You've hit it. At these kinds of bandwidths, copper wire just it fights back. The signal degrades incredibly fast.
So this NTI unit just gets rid of the copper.
For the long part, yes. It switches over to MPO-OM3 fiber optics.
Okay, let's pause on MPO for a second. That's not your standard single fiber optic strand, is it?
No, not at all. MPO stands for multi-fiber push-on. It's a single connector, but it's housing 8 or even 12 separate optical fibers.
So it's less like a single-lane road and more like a superhighway.
A perfect analogy. You need that multi-lane highway, because DisplayPort 1.4 demands a massive bandwidth of 32.4 gigabits per second.
32.4 Gbps. That is just, it's
Yeah.
huge. That's about double what standard HDMI 2.0 can handle, right?
It has to be that big. If you want to get a completely uncompressed 8K image from a source to a display 600 feet away, you can't afford to drop any data.
And that fiber setup maintains the full speed over the whole distance.
The full 32.4 Gbps pipe, which is what allows for the cool DisplayPort features like multi-stream transport and up to 36-bit deep color.
So let's talk about what that bandwidth actually gets you on the screen. We keep saying 8K.
The headline spec is definitely 8K, so that's 7680 by 4320 resolution at 30 hertz.
Okay, 30 hertz is maybe a little choppy for, fast-moving video or gaming.
It can be. But here's the really interesting part, I think. Because you have this enormous bandwidth pipe, if you're willing to lower the resolution, the speed just skyrockets.
Ah, so you can trade pixels for speed.
Exactly. It can do 4K at a super smooth 100 to 120 hertz. Or if you go down to 1080p, it hits an insane 240 hertz.
Wow. Okay, so that's flight simulator territory or high-end competitive gaming.
Precisely. You can put the hot, noisy computer in a server room 200 meters away, and the pilot or the gamer gets a perfect image with 0 perceived latency. And the color is bit perfect, too. It supports YUV 4.4.4, so no compression.
I want to look at the hardware itself for a moment because there's this weird power quirk in the specs.
The transmitter and receiver, you mean?
Yeah, the receiver at the display end needs a power adapter, but the transmitter, the part plugged into the computer, it doesn't. How does that work?
It's a brilliant bit of design. The local unit just scavenges power directly from the DisplayPort source itself. It only draws 0.2 watts.
0.2 watts. That's basically nothing. It's just sipping power from the graphics card.
It really shows you how efficient light transmission over fiber is compared to pushing electricity through copper.
Okay, but we have to talk about the price. This thing is listed for $1,015. For an extender.
Yeah.
That's a hard sell for a home user. Who's actually buying this?
You're not buying this for your living room TV. You're buying it for what the spec sheet calls sensitive application.
Meaning electronically hostile environments.
Exactly. This thing uses fiber, which is basically glass. It's totally immune to EMI and RFI. That's electromagnetic and radio frequency interference.
So places like factory floors with heavy machinery or hospitals.
Hospitals are a perfect use case. Imagine running a long copper cable past an MRI machine. That cable acts like a giant antenna. You would just pick up so much noise, the image would be destroyed.
Right. Or worse, you could get power spikes going back into your equipment.
You could. So this fiber provides total electrical isolation. You're paying $1,000 for a safety guarantee.
It's an air gap for your video feed. That actually makes a lot of sense.
Plus, the design is super compact. Installers can pull the thin fiber cable through a conduit pipe first, and then attach the extender heads afterwards. It's made to be built into infrastructure.
It really changes how you look at a giant screen in a stadium or an airport departure board.
It really does. We all obsess over the pixel count of the screen or the power of the computer, but it's this invisible plumbing, this light speed infrastructure that actually makes it all work.
A great reminder that sometimes the most important technology is the stuff we're not even supposed to see.